Right, so next up is learning target 23, which is solving exponential and log equations, and this is in 7.4 of your book. And this is all about solving equations. So we have, to start off with, we have a few properties that help us between thinking about exponential and log equations. So the first one is the one-to-one property. So because exponential functions and log functions are inverses of each other, they are one-to-one functions, which means that if you have a of x equals a of y, then that only happens, so if and only if x is equal to y. And the same thing happens with the log function, because that's also a one-to-one function. If you have log base a of x equals log base a of y, that only happens if and only if x equals y. Meaning, if I have 2 cubed equals 2 to the x, that can only happen if x equals 3. Or if I have log base a of x equals log base a of 3x, that can only happen when x equals 3x. So then x would not have a solution. Well, x would be 0. But then you couldn't have 0. That's a bad example to choose. But basically, this is the only case where that would happen, is if those inputs equal each other. In this case, no solution. You also have the inverse property. So we said exponential functions and log functions are inverses of each other. And so that says that if you have an exponential raised to a log with the same base, then they basically undo each other because they're inverses, and so all you're left with is x. And if you take log base a of something exponential with the same base, again, they undo each other, and so you just get x again. For example, if you have 3 raised to log base 3 of x, since those bases match, you just get x. If you have e raised to the natural log, well, let's do it the other way. If we have natural log of e raised to 2, and that's the same as 2. So we can start solving some simple equations using these properties. So for example, in this first one, we have 2 to the x equals 32. So one way to do this is to try to make the bases the same, to use the one-to-one property. Well, I know 32 is the same as 2 to the 5. And so now I have the base the same, which means that the exponents have to also be the same. So that means x has to equal 5. On this next one, I have natural log of x minus natural log of 3 equals 0. If I shift it to the other side, now I have natural logs on both sides. That can only be true if the inputs are equal. So x has to equal 3. We can also use this inverse property. So on this next one, I have natural log of x equals negative 3. In this case, we can use the inverse property. So we're going to raise both with e. So if I do e raised to natural log of x and e raised to negative 3, then the e and natural log undo each other, so we just get x on the left side. And on the right side, we have e raised to the negative 3, which you can type in your calculator if you want, or leave it like this for an exact answer. Same thing on this one, I have log base 3 of x, so I can use 3 to raise that up on both sides. And so then I get the 3 and log base 3 undo each other. We just get x, and then 3 to the 4th is 81. So generally, we have these strategies to solve these equations. The next type of the things you want to look at is, can you rewrite them with the same base? With the same base to use the one-to-one property? Or can you rewrite in exponential or log form, the other one from what you already have? We can also have a few more complicated equations to solve. So for example, in this one, we have e to the negative x squared equals e to the negative 3x minus 4. Well, we have e on both sides, so the bases are the same, which means we can take the exponents to equal each other. So we know negative x squared equals negative 3x minus 4. So I'll move everything to one side. I'll get x squared minus 3x minus 4. And then I can start factoring this. So this is x plus 1 and x minus 4, which means x plus 1 equals 0 and x minus 4 equals 0. So x is negative 1 and x is 4. At this point, we should check these solutions. When you have these quadratic things, it's always a good idea to check these solutions. In general, you should check the solutions to make sure that they actually work in the original equation, because we're shifting domains a lot. Especially if you added on some extra x's. Here we didn't really add an extra x, the x squared already existed, so it's probably not going to give us an extraneous solution, but it's a good idea to check just in case. In this case, if you check your solutions, both solutions will work. So you'll get negative 1 and 4. So we can do similar things on these other problems. Sometimes you'll have to do change of base things. So for example, in this next one, first I'm going to divide just by the 3. So something that comes up a lot is when you see something like this, it's very tempting to go 6 to the x equals 42. But you need to remember the order of operations on this. You do exponents before multiplication. So you can't multiply 3 times 2 until you take care of the x, which means this 3 is separate from the 2. So the only thing you can do here is divide by 3 on both sides. And then we need to get rid of the 2 to get to the x. Well, to do that, we'll have to take a log on both sides. So we can take log base 2. And then that undoes the 2 to the x, so we just get x. And then we get log base 2 of 14. Well, that can be natural log of 14 divided by natural log of 2. And if you type that in your calculator, you get about 3.807. Again, you should check the solution back into your original equation based on what the instructions tell you. So sometimes exact answers are what's needed. When we want exact answers, this is the exact answer, log base 2 of 14. If it tells you to round, then you can go to 3.807. Again, when we're rounding, standard rules is always 3 decimal places. So go up to there. There are a lot more equations on here for you to solve, to do as practice. So I would want you to go through each of these and practice them. I can post solutions to this on Google Classroom as well, so you can check your solutions. But I would have you do this as practice on your own. You also have a word problem at the end, so a lot of times you have these models to look at. In this case, this is really just solving this equation. It tells you what the p value is, the price. So you do 600 equals 5,000. 1 minus 4 over 4 plus e to the negative 0.002x. This is a complicated equation to solve. It's like these equations, right? They're just big expressions to have to simplify. It's possible, you can do it. I don't think it's particularly different on a challenge scale. It's just more tedious and more steps to do. But that's where you get to show your perseverance in solving these math problems and being able to get through the longer problems as well without giving up and just trying different things to get through it. So that's 7.4 and learning target 23, which is solving exponential and log equations.